If I were to magnify this like I did the other one, the carbon atoms will look like that. See, they're bonded to everybody. Every one of these carbon atoms has 4 neighbors, and they're tied really close to each other. That is why diamond is so strong, right? Because they're bonded very strongly. On the other hand, graphite is carbon too, but is bonded in a different way. They're made out of sheets, where every carbon atom has 3 neighbors, 3 close neighbors, and 1 very distant. And it turns out that the close neighbors are so tightly bounded, it's stronger than in diamond. But how come graphite is so soft? Because as I squeeze on them, I can peel the sheets away. That's why it's so soft. Every sheet is stronger than diamond, but the sheets are very soft in between. That's why. And so, how you make the atoms together makes a big difference. So in here I have a piece of graphite, right? Now this is on a foil because real graphite is a little tiny, and this is cheaper, it turns out. Now, now I can, you know, this is represented here. Every little ball is representing one of these carbon atoms. And what we've drawn here is lines that go like this, red, right, and dark, to illustrate, you know, what is the orientation. I can make different coilings of this sheet, then it looks like this. This is called an armchair nanotube, because if you look at the atoms at the top, that's what they look like a chair. Can you see that? And in that case, the red stripes are vertical. All right? They're vertical. Now, you can switch the sheet and fold it the other way, so that now the red bands are horizontal. Okay? So the same sheet of graphene, I just folded it the other way. And if you do that, when you make the atoms go on top of each other, you see the edge of that will look, it's called a zigzag because it looks like this. It's a zigzag edge. Right at the top, it looks zigzag. And I can make an armchair or zigzag, and it turns out that the armchair, the one we made first, conducts electricity. And it conducts electricity better than copper. While if you make it zigzag, like this, it does not conduct electricity. It's a semiconductor in the lingo. So the structure, right, the size and the structure, how you fold atoms together, matters a big deal.
my friends and I could always see my family. So I still want now, even if I'm here and I know they won't be waiting. Cause I don't want to be alone, no. I don't want to be here alone.